Let's talk about the first steps of beta oxidation, in which in the first step, for example, there is palmitoyl coenzyme A. I think it's around 20 carbon bearing fatty acid. Yeah, and then there is in the step 1, in the presence of acyl coenzyme A dehydrogenase. Dehydrogenation occurs at in between alpha and beta carbons, and this is acyl group. It's shown in pink, and dehydrogenation occurs here, and there is double bond formation, and it makes a double bond between alpha and beta carbon. In the second step, hydration of the double bond, it happens, or it occurs at this point, and OH is added in this side at the beta carbon, and hydrogen is added on the alpha carbon. In the step 3, dehydrogenation of beta hydroxyl group to a ketone, it occurs. See, from this beta carbon, hydrogen is removed, two hydrogen are removed, and carbonyl group, it appears here after dehydrogenation, and beta ketoacyl coenzyme A, it is this structure is produced. In the step 4, acylation, addition of coenzyme A and production of acetyl coenzyme A, it occurs. You see, addition of acetyl coenzyme A thio group, in the presence of thio group, it occurs at and this acyl coenzyme A, it binds with this beta carbon, and the group from here, this all is released. So this is acetyl coenzyme A, this one is released. So the same thing is written here. First of 3 stages of fatty acid oxidation is beta oxidation. Actually, this is related to beta oxidation. Here there are a few examples of fatty acid long chain, C4 bearing C6, because it is even number of carbon chain fatty acids mostly. So in this one, acetyl coenzyme A, 2 carbon will be less, and it will be removed from this fatty acid long chain, and this beta oxidation, it occurs or the loss of 2 carbons, it occurs in the stage 1, and acetyl coenzyme A, it in the next step, it enters into the citric acid or Krebs cycle, where carbon dioxide is produced, and in the stage 3, trans-respiratory process is occurring through electron transport chain, and huge amount of ATP is released. So energy yield from beta oxidation altogether is in case of stearic acid, taking stearic acid as example, that is having C18. So yield per mole of stearic acid, how many ATPs are produced? Let's see. During the activation of the stearic acid to produce stearyl coenzyme A, 2 molecules of ATP are used. So this is written as -2. In the next step, that is oxidation, oxidation and the production of FADH2, it takes it about 8 times, and 16 molecules of ATP are produced thus. And similarly, in the next step, oxidation, hydroxy acyl coenzyme A to ketoacyl coenzyme A produces NADH and H positive ions, and it happens around 8 times, and 24 ATP molecules are produced. Similarly, oxidation of acetyl coenzyme A to the common metabolic pathway, it occurs 9 times, and 108 ATP molecules collectively producing 146 ATP molecules. It happens during this beta oxidation reaction, which starts from the cytosol and ends up inside the matrix of the mitochondria. That's all.